So we finished up week 3, and there seemed to be a lot of people confused with the scale aspect of week 3. So I just want to, and I don't know if this is because people hadn't looked at the lectures yet or done the reading, but I want you to remember that there are notes and there's a text to read each week. And then I go over, my internet is like so slow right now. I do not know what's going on. It's probably because it's sunny out and even the internet doesn't want to work. And so in the study guide, well, that's week 2, dang it. The study guide, you can review the lecture on scale, and you can take notes as you go over that. So, but I'm going to go over a couple things that seem to be causing people some difficulty. One is you should have picked up your copy of the Eugene East topographic map. You will need that this week and next week, or you can download it. It's a little trickier to download. So that should be your copy. They're in the social science office just waiting for you with your name on it. And the first question says to make a ruler using the graphic scale at the bottom of the map. So you're going to come down here and using that graphic scale, which is the bar scale, and if you've done the reading or watched the videos, you would remember that. And you're going to line your paper up here, and this is a 2-mile line. Remember, there's an increment from 1 to 0 and then 0 to 1. So you're going to make, as long as your 8.5 by 11 sheet of paper will let you, so you should be able to make a very long ruler. And then the first question is, how many miles is it in latitude? So from 44 degrees to 44, 7 minutes 30 seconds. So that's 7.5 minutes of latitude. Remember, degrees, minutes, and seconds are measurements, points on the earth, and the distance between them is a measurement. And so also, how many miles is it from 130 degrees west longitude to 130 degrees 7 minutes 30 seconds? So that's really all that question is asking you, to make your ruler and to measure some distance. And then you're going to measure as the crow flies. That's an idiom that means in a straight line from the center building of campus to Otsum. And then use Google Earth and discuss the difference for you. Then I have given you a paper copy of a map that has no scale on it. So here's a map of campus. There's no scale. And your instructions are to determine the scale of this map based on this map that has a known scale. And what you're going to do is set up some ratio areas on here. So Topo length means the length of a feature on the topographic map. Unknown length means the length of the same feature on the black and white copy that you don't know the scale. And so what you want to end up with is a representative fraction that is 1 to some number. Again, you're not going to have any units. So what I would do is I would find something that's really easy to measure, that's pretty linear. And in class we did the little buildings just for fun, for people to see how close they could get. But if you measured from this point down to that point on the map with unknown scale, that would be your unknown distance. And if you zoom in and you measure that same distance here, that would be your known scale. And so your formula would look like this. You would put the length of of the thing, I don't know what you decided to measurement, on the topo map. And you're going to divide it by itself. And if you divide something by itself, you get 1. So that would be 1. And then this is the colon in your representative fraction. And then you're going to take the length of the thing on the topo map times the scale of that particular topo map. And then you're going to divide that. I'm going to move this down because it's kittywampus. And then you're going to divide that by the length of the same thing on the map with no scale. And that's going to give you some number. So your ratio fraction will be 1, or I'm just going to write it here, 1 to some number. And because you're using the same unit of measurement both on the topo map and the map with no scale, you can ignore the units as long as you're using the same ruler. So you can use the decimal ruler, you can do centimeters, you can use millimeters. The key is to get as accurate a measurement on 2 distances. So what you're doing is creating a ratio. And then you're taking that ratio and adjusting it for the scale of the map that you know. Okay, and then I'm going to ask you to convert to scales. So, for example, if I have a word scale that says 4 inches equals 25 miles, the easiest thing is to divide. Oh, I wanted to change that, sorry. If I have a scale that says 4 inches equals 100 miles, the easiest thing is first to get this down to 1 inch equals the same reduction in miles. Because remember, I want to end up with a ratio fraction of 1 to something. So I'm going to divide both of these by 4, and I'm going to get 1 inch equals 25 miles. Now, about a quarter of the students stop right there. That is, and they'll do this. 1 to 25, and they just chunk off the units because they can. Well, that's not the scale of this map. This is saying 1 inch equals 25 inches, or 1 mile equals 25 miles, and we know that's not the relationship here. So what you ended up with is 1 inch equals 25 miles. Now you have to convert those miles to inches, and when you have the same units on either side of that ratio, you can remove them. So I know that there are 12 inches in a foot, and I know that there are 5,280 feet in a mile, and I know that I have 25 miles. So I'm going to divide that up, and my answer then would be 1,2,1,5,8,4,1,2,3. And that would be my representative fraction, or my ratio fraction. And if you put commas in there, it makes it so much easier for me to grade. And then how do you do it if I give you a representative fraction? How do you convert that into back into a word statement? So the first thing is what you have is 1 inch, because it's a representative fraction, equals 50,000 inches. Well, that's kind of a dumb, not very useful word scale. So I want to convert the inches into feet, So I'm going to say 1 inch. Maybe I'm going to say that. And then I'm going to take that 50,000 and divide it by 5,280. So 1 inch equals 9 feet. That might not be a bad representative fraction on there. 1 inch equals 9.5 feet. But then you could also take it into miles, where you have 1 inch is equal to 9, I'm going to just round it up, 9.5, and I'm going to divide that by 12 to get miles. Is that what I'm dividing by? Yeah, 12 to get miles. I forgot the equal sign. So my answer is 1 inch equals about 8/10 of a mile. That's how you work that backwards. This is directly from the lecture video. Just I walk through that. That's the example on the lecture video, and you need to figure out New Hampshire, and then you work on the map projection lab.